I finally did it, guys. I got my hands on an electric water heater so I can finally do the sequel, the follow-up, the electric boogaloo to how to troubleshoot your RV water heater. That first video I did was just talking about gas water heaters. And so today we're going to be talking about the electric side of this Atwood Dometic water heater. If you don't know me, hi, hello, my name is Emily. I'm a certified mobile RV repair tech based in Las Vegas, and this is RV Repairwoman. Today, to test your water heater, you're going to need your multimeter. You're going to need to know how to set your multimeter to DC volts, AC volts, resistance, and continuity. If you don't know how to do one of these, head on over to my multimeter basics for RV owners, where I walk you through how to do every test on your multimeter that you could possibly need. You may also find it useful to get some needle nose probes for your multimeter, specifically for when you're testing the circuit board on your water heater. I know in a previous video I said I did not like these, and that's because I hadn't found these hat versions yet. These kind can just slip on and off of your probes super easy. In the past, I had only ever used ones where they were like a whole separate set of probes that had their own wires hanging off of them, and I was constantly getting everything entangled in each other, and that's how I once accidentally stabbed myself in the leg with one of these and gained my dislike of needle nose probes. These guys, super nice, super easy to take on and off, relatively cheap to get on Amazon. I'm sure there's a link in the description for these specific ones if you want them. Just make sure when you're getting needle nose probes that they say somewhere in the description or in the comments that they're gonna work with your specific meter. I originally just got a like super cheap pack on Amazon, and they did not work with my Klein probes, and I was sad. Then I got these and I was less sad. So just something to keep an eye on. They're not universal. So without a further ado, let's test a water heater. The first thing that we need to do when we are testing any appliance in an RV is find our known good ground. I talk about it in every troubleshooting video. When it comes to water heaters, it's going to be this green wire, and it's normally screwed right onto the side of the frame here, which means that basically the entire metal frame of this water heater is grounded. But just to be 100% super sure the entire time that we have our black probe on ground, we're gonna take our black probe and we're gonna put it on the screw that this green wire is attached to. And then we're gonna take our red probe and poke it around different parts of the water heater looking for voltage. So the first place I want us looking for voltage is on this white wire going into the circuit board. So we're gonna put our black probe on that screw, red probe most likely with a needle nose tip into that white wire. We're gonna set our meter to DC volts, and we are looking for something in the realm of 12 volts. Now, just like I've said in many other videos, this can range from anywhere between 11 to 14.5 and be a-okay. Anything less than 11, and I want us to go look at our batteries, make sure our battery's supplying good voltage. I wanna go check our fuses, make sure none of our fuses have failed in weird ways. If you are not getting something in the realm of 12 volts on this white wire, then you can close up the access panel to your water heater. The problem is not here. But if you are seeing something in the realm of 12 volts, we're gonna continue on to the next step. And that is to look for 12 volts coming out of this brown wire on the circuit board. So again, black probe on that screw, red probe on this brown wire, and we should be seeing something in the realm of 12 volts. If you do not see 12 volts, then the problem is most likely with your circuit board. Take a look over your circuit board, see if it has any fuses that you can take out. If your circuit board does have a removable, wow, that word is hard. If your circuit board does have a removable fuse, got it. Go ahead and take that sucker out and test it for continuity. If you need a refresher on how to do that, check out this video here. But if the fuse is good and you put it back in and you're still not getting 12 volts on this brown wire, then the circuit board is most likely your problem. Switch that bad boy out and you should be good to go. If we are getting 12 volts on this white wire and 12 volts on this brown wire, then the next place that we are going to look for voltage is on the Tstat. And yes, I'm going to call it the right thing in this video. So go ahead and follow that brown wire down to see which side of the Tstat it goes to. We're gonna go ahead and put our black probe on our screw and our red probe on the terminal of the Tstat that comes from the circuit board. You may need to pull the connector off of the terminal a little bit in order to expose enough metal to get your probe in. If that is the case, then I want you to put your finger on the middle of the Tstat and then use some needle nose pliers to very carefully walk that connector back a little bit. There is a spring behind that Tstat, and if we just start yanking on it, the Tstat is going to pull back and then get smacked back into the tank and could potentially break the Tstat itself. So just give it, you know, a little support with a finger. Don't we all wish we had a little more support in life? Support that Tstat the way you wish the world would support you. And again, we're looking for something in the realm of 12 volts. You really should be seeing 12 volts at this pin. If you had 12 volts at the circuit board and you don't have it at the Tstat, check the wire, I guess. You really should be having 12 volts at this pin. The only thing in between these 2 points is a wire. Make sure your connections are good, but this was really just a formality. You should have 12 volts here. So now that we've confirmed that we have 12 volts going into one side of the Tstat, we're now going to move over and make sure we have 12 volts on the other side of the Tstat. Black probe on that screw, red probe on the Tstat, and looking for something in the realm of 12 volts. If you have 12 volts on one side of the Tstat but not the other, then the Tstat is your problem. Woohoo! We can double check our work by very carefully disconnecting the wires from the Tstat entirely, so it's just sitting there on its own, living its best life. Again, support it with a finger while you do this. Set our meter to continuity, put one probe on either side of the Tstat. If we have continuity, then the Tstat is good. If we do not have continuity, then the Tstat is bad. If you're at this point in the video and you're like, Emily, I am just so confused. This multimeter life just isn't for me. Totally fine. I see you. I hear you. If you're in the Las Vegas area, hit me up at rvrepairwoman.com. I'd love to come help you out, and I can even walk you through this process with you so you feel more confident doing it on your own the next time. You got this. If we have 12 volts on white, 12 volts on brown, and 12 volts on either side of the Tstat, then the next place that we are going to look for voltage is through the thermal cutoff. Woohoo. Thermal cutoff is usually connected straight to the Tstat and then to a brown wire that's heading back to the circuit board. So presumably if we have 12 volts at the Tstat and we've connected the thermal cutoff to the Tstat, that side should be good. So black probe on that screw, red probe going into the side of the thermal cutoff that is attached to the brown wire, and we're looking for something in the realm of 12 volts. You're gonna find these videos are pretty repetitive if you've watched a couple of them. Diagnosing these things can be pretty easy once you know what you're doing. If you have 12 volts at the Tstat, but not on the far side of the thermal cutoff, then the thermal cutoff is most likely your problem. You can double check this by disconnecting the thermal cutoff from the Tstat and from the brown wire, so it's just hanging out in space all by itself. Set your meter to continuity and put one probe on each side of the thermal cutoff. If you have continuity, then the thermal cutoff is good. If you do not have continuity, then your thermal cutoff is bad. Switch that bad boy out. You should be good to go. Woo! And then finally, the last place that we are going to be looking for DC voltage before we switch our meter over to AC is on this brown wire at the circuit board. Black probe on the screw, red probe on the brown wire, looking for something in the realm of 12 volts. The two things that we just checked, the Tstat and the thermal cutoff, are in place to make sure that this water heater isn't too hot before we go ahead and turn on the heating element. So the Tstat stands for thermostat. It's just checking to make sure, is this tank too hot? And if so, shuts everything down, doesn't let signal through. The thermal cutoff doing something very similar, as you can tell from the name. If it gets too hot, it cuts off signal. So we've done some safeties. We've made sure the tank isn't too hot. If we have 12 volts on the white wire, 12 volts on the brown wire, 12 volts on the Tstat, 12 volts on the thermal cutoff, and 12 volts on this other brown wire, then it is time to Ooh, I totally lied. There's one more place we're gonna look for DC voltage. The last place that we are going to check for DC voltage before we switch our meter over to AC is looking for voltage on this yellow wire. That yellow wire is how the circuit board sends a signal to the AC side of things and says, hey, I've done all my safety checks, it's time for some heat. So if you have 12 volts making it all the way to this brown wire, but you do not have 12 volts on this yellow wire, then that circuit board, most likely your problem. Again, look it over for any fuses that you might be able to take off and test. If all your fuses are good, circuit board's most likely your problem. They're a little pricey, but you at least diagnose the problem by yourself. I'm proud of you. You got this, okay? So we have done all of the DC side of things. When it comes to RVs, you have two different types of power. You have DC and AC. DC is lower voltage and tends to be the brains of things. That's how we make decisions, like going through the Tstat to make sure it's not too hot, going through the circuit board to decide whether or not we should turn the water heater on. Then we need to kick over to AC power to really be our muscle to actually start heating things up, okay? So this is where on most of these water heaters, you're going to need to go find the back of the water heater, which for me right now is gonna be relatively easy. I'm just gonna turn this sucker around. For you, that is most likely gonna involve opening up some cabinets, sometimes it's under a bed. You're gonna need to do some digging through your RV to figure out how you can get to the back of the water heater. The stuff that we're gonna be looking at next is going to be hiding in a black box towards the back bottom of the water heater tank itself, okay? On some of the newer ones, you can get lucky and they've started placing it towards the front, but for most of these Atwood Dometic water heaters, they're in the back. So just give me a moment to turn this water heater around. Turn the heat around. Love to hear percussion. So here's the back of our water heater. Ignore this crazy ass pipe. This is the main reason that I had to take this water heater out for somebody. Just bonus tip with this video. Don't try to fix RV water leaks by covering the pipe in fiberglass. PEX connectors are relatively cheap and easy. If you need a video on how to do them, let me know in the comments. But this poor customer had to replace an entire water heater that otherwise needed some love, but we could have gotten working because the previous owner had covered this pipe in fiberglass to try to stop a leak. And there was no way for me to get this fiberglass off without damaging the tank. And I was at a point where like the cost of me doing that, we were just getting to the point where the customer was like, let's just get it. Let's just cut it out and get a new water heater. And I think in the end, it was the right choice for that customer. And it means that I now have a broken water heater, and isn't that the best gift of all? Now that we're at the back of the water heater and we found this black box, the next thing we're going to do is disconnect it. I would recommend going and turning the breaker for your water heater off before you take this box off, just for safety reasons, okay? So go ahead, flip that breaker, remove these two nuts, and this box should come right off. When it comes to the back of this water heater, there's only three things hiding back here. Your AC power coming in, the relay, and the water heater element. That's it. I'm gonna show you how to test all three. We're actually going to go backwards in order because the water heater element is the easiest thing to test. So we'll work our way to the more complicated thing, which is the relay, but we don't need to touch that if we can figure out that it's the super easy thing to test. Okay, hope that stuck with everybody. So to test the heating element, just give the box a once over, make sure all the wire nuts look good and tight and that nothing came off while you were taking the black box off. If everything looks good, go ahead and throw that breaker for the water heater back on. And then we're gonna take our red probe and put it on one of these two screws on the water heater and take our black probe and put it somewhere on the tank. On one of the screws, you should see a reading in the realm of 120 volts AC. And on the other screw, you're gonna see something significantly smaller. I'm talking like something in the realm of 3 to 5 volts. If you are not getting 120 volts to either side of the heating element, then that means that something upstream is your problem. It's either gonna be the relay or the AC in, and we're gonna test those next. If you're getting 120 volts to one side of the heating element and on the other side, the number hasn't drastically reduced. Again, talking, it should be like 3 to 5 volts. Then this heating element is most likely your problem. The way you can double check is go throw that breaker again, so we're not sending AC voltage to the water heater at all. We're then going to unscrew the 2 connections and disconnect the wires going to the heating element. Then set your meter to resistance. Remember on these Klein meters that is hiding in the same setting as continuity. We're just going to set it to the auditory symbol and then hit the orange button once so that we're on resistance, not continuity. Put 1 probe on either side of the heating element, and you should be seeing a reading in between 9 and 11 ohms. Make sure it says ohms and not milliohms. If you are outside of that range, less than 9 or greater than 11, then this heating element is bad. Lucky for you, they're super easy to replace. Just drain the tank. Go ahead and unscrew it. I think if I remember correct, it is a 1 1/2 socket. You're most likely going to need to get a specific water heater heating element wrench. They sell them at Lowe's, Home Depot, all the good stores. It just unscrews out of there like a bolt. Get a new one, screw it in, reattach the power, and you should be good to go. Okay, can you see why we started here? The connections are super easy to get to. Everything there is super easy to test. If you are getting 120 volts on one side and a reading that makes sense on the other side, you're getting something like 3 to 5 volts, but the tank is not getting hot. That is actually exactly what was happening with this water heater. Everything on it was working electrically, but it still wasn't getting hot. Then you most likely need to clean your water heater. There's a chance that that heating element is so covered in calcium and debris that its heat isn't transferring to the water. Editing Emily here. If you want a step-by-step tutorial on how to do a clean out on an RV water heater tank, check out in the description. I have my ultimate guide to RV maintenance, which not only walks you through how to do this, but also a bunch of other really quick and easy RV maintenance tips that can save you tons of money in the long run and keep you from having to call me, as much as I'd love to come out and see you. So yeah, check that out. It's free and I made it for you. My gift to you. Back to the video. The basics of it is you're gonna drain the tank, fill it with vinegar, let it sit overnight. Next day, drain it out, flush out all the vinegar and all of the crud that's gonna come out with it. Refill it with water and you should hopefully, fingers crossed, be good to go. You can also look at replacing the heating element, even if it's testing fine. If it's just so covered in crud and we can't get that crud off, just pull it out. If you see it's covered in crud, replace it with a new one and that should hopefully help. But if you're not even getting 120 volts to this heating element, then the problem is either with your relay or with your AC in. So the next thing we're going to test is the AC in, because that's the next easiest thing to test. So you're gonna see 3 wires coming into this box. There's a black, a white, and a green wire. With power on, you can put your red probe into the black wire nut and your black probe into the white wire nut. Now it's a little counterintuitive there. You should see a reading in the realm of 120 volts AC. If you do not, that means power is not making it to the water heater, okay? This is the only way that this heater gets AC power. So if we are not seeing 120 volts at these wire nuts, then we wanna go check, is our breaker on? Is our pedestal good? Are we getting AC power to other things? Like, is our microwave turning on? We need to start looking upstream because the AC problem is not with the water heater. If we are getting 120 volts to the AC in, but we're not getting 120 volts to the heating element, then the problem is most likely with this relay. But we can double check just to be sure. So let's turn off the water heater entirely and throw the breaker off for the water heater. So there is no power going to this bad boy at all. And then disconnect the relay entirely from the system. It should have 4 wires going to it. Disconnect all of them. Then with the relay just sitting there minding its own business, you want to check for continuity across this pin and this pin. And you're hoping at this moment with the relay just sitting there that there is no continuity. Then you want to supply 12 volts to this pin and this pin. I usually do that with a Power Wheels adapter for my DeWalt battery. But if you want, you could just re-hook up the yellow and green wires that were coming to the water heater and turn the water heater on. Just any way for us to get 12 volts to go to those two pins. And then with 12 volts going to those two pins, check for continuity to these two pins again. At this point, you should have continuity. If you do not have continuity between these two pins when it is receiving 12 volts, then your relay is bad. Switch that bad boy out and you should hopefully be good to go. So just to review the back here, the flow of things is AC in to a relay to a heating element. I usually, as a tech, test these things in reverse because the heating elements are so easy to test. And that's about it. That is how you test the electric side of an Atwood Dometic water heater. If you found this video helpful, please consider hitting subscribe. I put out videos like this on the reg. This has been RV Repairwoman. You got this.